All right. Hey, that is our little song of the week right there. Someone give it a name. All right. Hey, I'm John Park, and this is John Park's Workshop. Welcome so much for coming by today. Let me stop that little pocket operator thing, and you know what? I'm going to move that camera, so let me hide that so you don't get seasick while I put that back on the workbench. All right. So, hey, thanks for stopping by today, and thank you everyone in the chat for letting me know that I wasn't playing audio there for the first few minutes when I thought I was. That's why we do the pre-show with the song. Yeah. So I'm here from Adafruit Industries, in your home, on your internet, in your cubicle if you're at work watching, on the train if you're doing a commute and have good cell reception. We have all sorts in our chats and in our audience. So thanks for coming out. We got a lot of people over in the Discord chat, and we also have people in the YouTube. I'll be watching those. And if you're on Twitch or Periscope or Facebook, I'm sorry I don't have enough brain space and multitasking to check all of those. So welcome. We have a fun show in store for you today. I will kick it off with a coupon code. So the coupon code today is sclera. That's right, sclera. And if you're not familiar with eyeball anatomy, that's the white part of your eye. That's the sclera. That is a coupon code that'll get you 10% off in the Adafruit store on anything that you can imagine that you can throw in that cart other than gift certificates, subscriptions, and software. So if you are interested in picking up some stuff, maybe you want to buy some of the things that we're going to use in our project today, which, as you can tell from the little title there, is something to do with an animatronic eyeball. Excuse me. If you've been watching our Instagram, I posted a little something there and on Twitter last night showing a little preview of what we're going to build today, which is an animatronic eyeball. So use sclera in the Adafruit shopping cart to get 10% off. Let's see, what's next? Oh, so speaking of shopping carts, product of the week. So normally the product of the week is something that I'm using in the build or something that I've been working with that I'm very excited about. This is a first. This is something that I don't even have yet. It just came out. It's the Itsy Bitsy M4 Express. Itsy Bitsy, I have a regular M0 Itsy Bitsy. No, I don't. Do I? No, I have a 32U4. There we go. Is that a Itsy Bitsy? Yeah, I don't even have, oh, here's an M0. Yeah, so this is yeah, I have one left. So the new one looks an awful lot like that, except The chip on the new one is the M4, which is a ATSAM-D51, ridiculously fast. What's this thing running at? 120? Is that right? Someone, let's look at the specs here. I'm gonna pull one up real quick on my internet browser. This just came out. I haven't gotten one yet, but I'm excited about it because the M4 chip has a lot of cool features, including lots of RAM, being super fast. Yeah, it's running at 120 megahertz. It's Cortex M4. It has 512K of flash and 192K of RAM. And I just heard Lady Ada say last night on Ask an Engineer that she ported the PJRC audio library to it, which is from Paul Stoffrigen of Teensy fame, and it's an amazing library for doing digital signal processing, audio processing. I've used it on the Teensy 3.2 and 3.6 recently for some projects, and I'm excited to see what it's like running that on this little Teensy. Not this one, this one's the M0, but on the M4. That's going to be amazing. Also, the M4 has two 10-bit digital to audio converters, DACs, so you can output real audio on two channels, which is pretty exciting if you're thinking of integrating it into a modular synthesizer like I'm thinking about doing, or other things where you want a couple of different audio signals coming out, maybe something to control a device, maybe something that you're listening to that's being signal processed. So pretty exciting stuff. Check it out. Yeah, C. Grover, 120 megahertz. What the heck? These things are amazing. So it's like $14.95 before your 10% off discount. Remember I mentioned Sclera. That'll get you 10% off of this little beauty or anything else you throw in your cart. So I'm going to get one soon. I have full confidence that it's going to be awesome. That's why I'm willing to call it the product of the week. And let me know in the chat if anyone has already gotten theirs and has had any fun projects built with it already. I imagine it'll drop in pretty easily as a replacement for any itsy bitsy M0 projects that you have and beyond. John K. Schaffstyle in our chat over on the YouTube chat said that he has one on order and it's supposed to arrive tomorrow. That's exciting when you get the package in the mail on a Friday. That's going to be a good weekend. Okay, so now moving right along. I'm trying to make sure we have enough time for our builds. I've got a couple little things we're going to build today, the main project, but also we're going to do a little lead-in sort of tools and techniques project that'll lead us to that. But first, it's time for the MakeCode minute. I really should turn on the echo effect on my little mixer there. Oh well. So the MakeCode minute today, what we're going to do is take a look at using MakeCode. Here's our friend MakeCode, to program a Circuit Playground Express running on the Crickit for Circuit Playground Express. So let me pull some wires off of this one and hold it up. So that right there, we're going to program that. And last week I mentioned that MakeCode in the beta version had support for the Crickit, as well as this green screen that I've been using so that I can live among these little blockly blocks. Well, that's out of beta. So if you just go to the regular old makecode.adafruit.com, all these features are in there. PT mentioned it last night on Ask an Engineer. Let's see, mine's fallen off the screen there, so you can use your imagination. But among the new things, you can see me highlighting over here, is high contrast mode and green screen mode. So I've got green screen turned on. If I turn that off, hey, where'd I go? But if I go to green screen on and click on the little green background choice, boom. I'm using web broadcasting software, Wirecast, so I have layers, but you don't have to do that. If you want to just do a straight up screen share of your MakeCode session, you can, in this green screen section, select one of your cameras. So if you have a webcam, I have a few of them plugged in, but if you have a regular webcam or FaceTime camera on a Mac, that'll show up as a background in MakeCode, so that's pretty cool. Okay, so as usual, you can see cooking show style. Oh, there it is. I've got a little preview of what we're going to build today. The idea for today's MakeCode Minute is I want to use a capacitive touch sensor, the one there's 4 of them built onto the Crickit. I want to use one of those to control the angle of a servo motor. So here's the build. I've got a Crickit with Circuit Playground Express. I have a hobby servo, it's one of our standard Tower Pro SG5010, and I've hot glued a popsicle stick onto the servo horn so that we can see the movement a little better than just the little black piece of plastic on there. So with the, if you're not familiar with servos, they have 3 wires. They have a signal wire, which is this yellow wire here, power, which is red or orange sometimes, and ground, which is brown or black sometimes. On the Crickit, we can plug that into any of these 4 ports on here. I'm going to plug it into servo port 1, and I'm going to plug it with the signal wire facing out away from the center of the board. So like that. That's the proper way to do it. With that plugged in, I'm going to plug it into USB for programming on the Circuit Playground Express. And now it's ready to be programmed. It's actually gone into its bootloader mode, so it's ready for me to drag a program onto it. So what we want to do is rotate this servo using one of these capacitive touch sensors when I touch it. So if we look over here at MakeCode, here's how you do it. I'm going to, in my forever loop, so let me make a new one, and I'll disconnect something from that and delete that old one. I can go to, I've already set this up, you saw me do it last week. I can go to Extensions and choose Crickit. And that loads up the Crickit package for MakeCode. So now I have options, new options in this category section. And under Crickit, what I'm going to do is I'm going to set the servo 1 angle to 90 degrees. If I load this onto my board right now, it's just going to move the servo to the center position, 90. So the servos go from 0 to 180 if they're a typical type of servo, which this one is, and so 90 is in the middle. Now what I want to do is I want to control this value. Instead of just being 90 degrees, I want it to be a number that's derived from me touching the capacitive touch sensor. So if we look again in the Crickit category and head down here to the bottom, there's a touch section. And if I drag that up and in, I'm going to put that right on my forehead so you can see it. It says Crickit read touch, and then we can pick 1, 2, 3, or 4. So we'll pick touchpad number 1. If I use this right now, there's going to be a problem because that capacitive touch sensor's values that it reads are roughly 190 units to 1023 units. That's about what we tend to get on this board with the current calibration. These things will become more advanced as we bang on this program and as you bang on this program and give us feedback so that you can calibrate and tune them. I just happen to know those values. I looked at the REPL inside of Circuit Playground Express while or rather inside of Moo, while I was running a Circuit Playground or Circuit Python program on it. So that was convoluted, but long story short, I know those values are around 200-ish to 1023. When you press it, you get closer to upper 900s. So what I want to do is I want to remap those values into roughly 0 to 180 degrees. So what I'm going to use is in the circuit, in the MakeCode math section, we have this really handy node here called map. So what I'm going to do is map the Circuit Playground read. I just dropped it in here so it's a little more solid and you can read it. So the map function is going to take whatever value is read on the Crickit's touchpad 1, and then it's going to map those values from a low of, and I'm going to say, let's say 300, to a high of, how about 900. And when it takes those values, it's going to remap them to whatever range you put in here. So I'm going to put, say, around 10 to around 1070. A lot of servos don't quite go, whoops, that's a big number, 10 to about 170. A lot of servos won't go fully to those edges without bumping into internal gearing or parts or something. I'm not quite sure why they don't always give you as promised. Sometimes you may find they will, but I will often start a little lower and see if that's enough range for what I'm doing. So that is it. That is our whole program. So what I'm going to do now is download that save that file, and now I'm going to drag it onto my Circuit Playground Express. And I'm really going to do it so that I'm not just using one that I had on there before. So it has just reloaded, and now let me show it to you. So here is my Crickit. Does not have a power plugged into it right now, so I'm going to grab, this is a 5-volt, 2-amp wall power supply. You could also use 3 AA alkaline batteries. So when I plug that into there, I can then turn on the Crickit's power. Is it on? Yeah, it's on. I can see there's a little green light there. And let's reset the Circuit Playground Express, because when it starts up, it wants to see that the Crickit is there so it can start communicating with it. And now, if I press that, so it's kind of nice because you get a fairly fluid motion using that capacitive touch sensor, sort of like you would with a potentiometer, unlike a button, which is going to just sort of jump the value directly. So here you can see we get the nice little sort of puppeteering control for our servo using basically one block inside of MakeCode. So it's really fun to prototype stuff in there. I really like the visual design of it. It's a very easy way to sort of map your thinking and your logic of what you want to do directly into action. So that is the MakeCode Minute today. I hope you enjoyed that. And let's see. So over in the chat, Dave Estelle said he has a couple of the Itsy Bitsy M4s. Haven't done anything yet, but queuing up a project. Excellent. Yeah, I'm really looking forward to that. Also, there was a question. I'm curious if anyone in the chat can answer this. Maybe someone from Adafruit if they're around. Now that we have the Crickit for Feather, or the Crickit Featherwing out, can we use multiple of those with one feather? I'm assuming you can, because it's I²C. So if anyone has like a very ambitious project and they need multiple drivers for lots and lots of motors or something like that, this was a question C. Grover had about, hey, can we sort of use some extension jumpers and gang up one feather talking to a whole bunch of these guys? I kind of am guessing yes, but I haven't tried it, and so I'd love to know if there's anything that prevents that from happening. Of course, there are other ways to have multiple microcontrollers talk to each other, so if you need to, where there's a will, there's a way. Yannick asks, what's the advantage of an Itsy Bitsy over a feather? Well, the Itsy Bitsy is less expensive and smaller. The M4 is a more powerful chip than anything we have on the feather yet, although don't ask, don't tell, but there's a feather M4 probably in our futures. So it's probably one of the smallest, least expensive boards that has the M4 on it. Yeah, that's about its size if you're doing a project where you need something very small. Otherwise, Feather has a lot of good stuff on it, like power management. It can do battery charging for LiPos, which is super convenient. Lots more pins are broken out. What else? I'm sure there's other things I'm not thinking of. But yeah, they have their pros and cons. If you can get away with smaller, less expensive boards for the project you're doing and need fewer pins, that's a great way to go, I think. All right, let's see. Okay, so let's move on now to our tools and techniques. So, dun dun dun, tools and techniques today. What I'd like to do is jump over to the workbench. Let's throw up the workbench cam and hide that little beauty there. And let's put let's put this one in the corner. All right, there's a little tease of what we're going to do for tools and techniques. So this is actually kind of a mechanism tip today. And so let me fire up my little chat machine over here and find the new live video of us right here, right now. Yeah, Yannick asking about the different boards. If you can get away with like gemmas or trinkets for projects, amazing, because they're just so small and they just do a few things really well as far as I/O goes, but the chips are very, very capable on them. So that's one way I'll think about stuff, is like gemma or trinket, and now what used to be sort of a Crickit Pro sized thing, but is now itsy bitsy, and then moving up to feather. It's pretty rare at this point that I would need something bigger than a feather. I have some Metro M0s and M4s that I use in projects, and they're actually really nice to have as, you know, kind of grab one. Oh, now I'm missing all of them. Usually I have one around to like plug in some NeoPixels and test a thing, and they're just nice big boards that are easy to manage and deal with. But feather pretty much has the same capabilities as a Metro board. Let's see. Let me pop out the chat here. Live chat. Will that let me pop you out? No? All right, let me just hide the, or I'm going to pause that video because that's distracting. There we go. Let's see, John Schaffstyle says, multiple Crickets should be able to be used if the I2C address can be changed. Right. Yeah, that would be the key thing there. Good point. Okay, so on to our mechanism. So I want to talk about building a gimbal. So let me make this the big screen. Hopefully my little camera controller is working. It is. So here I have a couple of toothpicks and a little tiny scrap of cardboard and some hot glue. And what I've made is a 2-axis gimbal. So I can rotate side to side, and I can rotate up and down, which means I have this really nice freedom of movement with a pretty simple mechanism. And there are a couple different ways of doing this sort of thing. Oh, let me get that back in the camera's view, sorry. You can see from the side here. So I am freely rotating around this longer toothpick on this axis, what I consider like a y-axis, and then on this x-axis, we'll call it, this is freely rotating in here. So this is a mechanism that'll be really useful for us when we want to do our project today. Oh, look, this is upside down, isn't it? Let me flip that over. That's better. Woo! That was looking weird to me. I had that flipped to look at the pocket operator earlier. So this mechanism is, if you think about the, let's say the front of this stick here as a pupil for our eyeball, if we were to rotate a half dome or a half sphere up and down and left and right, we are very close to, it's not perfect, but we're very close to, with this little simple mechanism, having the pivot points in the same spot for these two axes, which is what we want for something like an eyeball movement. So let's build a bigger version of this thing so we can take a closer look at how that works, and that'll help us in building our project where we're going to add some electronics and software to it, of course. So let's see. I think what we'll do is try to make it big-ish. So I don't have this pre-planned that much. So this will be kind of live building and thinking here. I think I'll use some of these dowels that I got at the craft store. And if we need to, maybe even use some drinking straws as kind of a bearing sleeve so that we get less friction. So to build something like this, what we'll need, and we can kind of copy what I built before, what we need is sort of a U shape. So this will be a little too big, but what I'm going to do is cut this down to size, like so. I guess I can put that camera in a little closer. I just changed this blade, so this should be cutting nicely. There we go. And you can eyeball this, or since I'm going against the grain, I kind of want to mark it, and yeah, let's say we'll do about 7, let me grab a pencil, we'll do about 7 centimeter bends here. It's a little long on that end. And one thing I like to do if I'm going to bend this cardboard against the fluting grain is just give it a little press with the side of a straight edge so that we zoom in a little closer there so we get a nice crease. And if you want, so that it can bend in on itself a little better, you can put a neighboring one so we get sort of two little 45-degree bends when we start folding this. Okay, so that makes for a nice little bracket here. And then let's trim off that excess length. I'm just going to eyeball that. Doesn't need to be precise for our needs here. Okay, so what we can do is just put in a couple little triangle braces with some hot glue so that this keeps its shape nicely. Since we're not making a full box, we'll leave the top of this open. And these are still looking a little long, so let's trim this down. Again, you can be kind of quick and loose with cardboard, especially when you're sort of figuring out your technique or your mechanism before you're either going to do it out of different materials or more precisely or change the scale of it. So that's pretty good. And then I'll just take some of this excess and turn them into some little corner braces. So I'll cut them down to roughly a square and then cut them into triangles. And again, you can be pretty fast and loose with this, just don't cut yourself. So now I'll just take hot glue and I'm just going to go around this edge of the corner. Get that out of that camera's view. Like so. Just careful not to burn yourself on the glue. And just hold that while that cures or dries or cools. You can use white glue for this as well. And then we'll do the other side. And same thing. Okay. And I'm just going to set something here to keep that from moving. Oops. While I let that cool and still have a hand free, just I'm trying to go fast. So let's see what we'll do. I'll put a set of these on the other side. So let's see if we can encourage that to cool off enough that it will stay. I think that's close. I'll flip it over and do the same thing on this side. You could also build up little blocks of these triangles and put them as braces on the inside, and that'll give them some pretty nice rigidity. But the cardboard shores up nicely, so it'll be pretty strong for our needs. Another thing you can do is double it up. So we could take this exact shape and fit it around itself to get a second layer around the outside. I don't know if we'll need that for this. It's got a little bit of flex to it. You know what, I'll save us the time of not doing that, but I will put a bead of glue right on the inside of that edge. That essentially is like bracing it with a lump of plastic by the time that cools. All right, so let's see if I have some, yeah, I've got some compressed air. I'm going to use that trick to cool this off. I'm running out of compressed air, but I think I've shown you this trick before. You turn your can upside down and freeze it. And instant curing of hot glue. You can see the frost right there. Smells good too. That's probably not good for me. But. All right, so now we have a pretty decent little bracket here. So what we want to do is mark off, I'll measure and mark off the centers. And then one way you can do this is just by drawing some corner to corner lines, and wherever the X is the center. I'll do this on one side. Since I didn't measure the two sides, they're probably a little off, so I can now take a measurement at that point for the other side to transfer it. So that is about 2.5 centimeters from this side. So we'll come over here and do a 2.5 centimeters. It's easy to get flipped around. And we'll go from the bottom up about 2.8 from the bottom. So 2.8. I know I'm only measuring once, so I'll probably get it slightly wrong. Okay, and now you can either take your X-Acto knife, or I've always got my handy dandy, what do you call these, safety pins? How to say? Safety pin. And hey, True Tech, that's trippy, the freezing effect. Yeah, it is kind of trippy, huh? There's still some huge question mark as to where I learned that. I can't remember if Gareth Brandwin told me about it or if I told Gareth about it. And if I told him about it, where did I hear it? Because I didn't just invent it out of thin air. If anyone knows the origin of that curing your hot glue with upside down compressed air trick, please let me know. All right. Oh, by the way, we've been having DigiKey people on in the chat on Discord lately. I think they're going to be on tonight again, and I'm reminded of them because I keep using these DigiKey boxes as my cardboard material. All right, so let's now, what we want to do is just bore that out a bit so that this axle will fit through. And you can use an awl or a screwdriver or whatever kind of pokey tools you like to use. This one works pretty well for these. This little kind of hardware store version of a dental pick. And now we can run that through like so, and our mechanism will move nicely through this axis. So now what we want to do is, if we look at our little miniature version, this long stick I have through here represents this y-axis, and now I want to put up some sides so that I can support this x-axis. So I call this y, right? Y and x. Some people call that z, depends on if you come from CAD or animation software, these things vary. Yes, hey Nate. Yeah, Nate Larson says in the chat that they're going to be on Discord tonight. Awesome, that was a fun time last week, so stop by if you want to ask questions about snowmobiles and electronics and other good things of our fine friends at DigiKey. Okay, let's see. Let's switch cameras for a second, because why not? All right, yes, so there's that little guy there. Okay, so now we have this axis working nicely. What I'm going to do is I'm just going to run some strips across the sides that I can poke through my other axis and make that piece. So here's my other section of cardboard. I could run this up along the sides and kind of take advantage of gluing it to some of these parts. I should probably have a wider piece than that for this, but you know what? We're going to just go with what we've got. So what I'll do is mark those. Let me switch cameras for you again. And you're on that one, right? Nope. That one and that one. All right, get this up here. I hope I'm not out of camera too much. This is a little bit zoomed. All right, so we're going to make a affordance for those little triangles I put on there. And again, I'll just give that a little crease and a neighboring crease to kind of fit around the thickness of the material. That should work pretty well. Yes, that's good. Like I said, it's not quite the right size, but that's okay. We're just going to stick it to this one wall, and that'll be all right. So I'll cut these down. Let's do them precisely this time so we can take advantage of the center finding technique. So let's do 5 centimeters from that outer crease. And again, here I am just hoping that I'm getting that straight. I'm not measuring in 2 places, which is not the best practice, but again, this is sort of a rough prototype. You can see that's not quite straight, but I'll fix it a little bit in cutting, sure. And hope I'm not getting out of there. Oh yeah, we have a spammer in our midst. Is there anyone here who can ban that? Can I do that while I'm talking? Oh, that's YouTube. No, I can't do that from here, can I? I can. I will hide you. Goodbye. I got the power! All right, so that will fit on like so. Let's go ahead and glue that in place. So I'll hit the bottom of it and these sides. I don't know if we'll reach those sides. If you blob enough hot glue on, you kind of tend to reach whatever gaps you need. It's a good gap filler besides being an adhesive. Yeah, I didn't cut those even, did I? Huh, how'd I screw that up? Oh, I went on the outside of the line. That's no good. All right, so we will measure distances so that we can get through this thing without being crooked. Again, you can imagine this will work even if it's a little bit off. And I used this to sort of visualize the mechanism I wanted to create for an eyeball, but you could imagine that the technique will hold up and be even better if you're precise if you're more precise in your measurements when you're doing this for real. Okay, so what we're going to do now is we're going to be able to turn the whole bracket or gimbal piece on this axis, and then we want another one running through. So what I'm going to do is I'm actually going to cut this dowel down a little bit. You can get away with using strong scissors on these. Just don't cut a finger off. And now what we're going to do is run this through here. So I'm just going to, here's a lazy technique. I'm going to poke it in a somewhat arbitrary spot that looks okay, and then make a mark with the dowel on the other side so I know where to cut. Hole number 2. And I can just do that like so. And then poke it from the inside. This little hook side of these is useful for that, so you can get a 90-degree angle. And now I know where the hole is, and I'll poke it through from the other side. And it's off, but not terrible. Okay. So let's see, just to make a object coming off of this that we can grab and rotate. Boy, that's definitely not straight, but oh well. I'm gonna hot glue a little chunk of the same material on. So I'll take another dowel and just chop off a little piece of it. And you can imagine if you place a third, you can get a third axis, so you can get a fully 3D, like yaw, pitch, and roll, if you have an object that can spin freely around this axis. So it's not a big leap to go from your 2 axes to a third axis. And hot glue is strong stuff, so I'm just going to leave that on there. You could use 2 different sizes of dowel and drill through one to place your post that's coming out of it. There's better things you could do than what I just did there. But now you can see, we'll let that, we'll make that cure. How about? Let's use our little trick here. Freeze up. All right. That does it. Ready? Yeah, strong stuff. So here we go. If I kind of hold that tightly, now you can see we have any little nice point on essentially the X and Y on this plane. We can reach it. Okay, so now what we're going to do to translate this to our, let's go to this camera. Yes, that's good. What we're going to do to translate this to our eyeball is let me see, the way I've got it set up, we will be able to use one servo to push and pull, like so. So that's looking down and up. And then we will have a second servo that rotates. Oh wait, I've got that backwards. How do I want this? Okay, like this, down and up, and another servo that pushes and pulls left and right. And so if you think of that front of that thing there, let me put a little, there's something colorful you can see. I'll put this yellow rubber band on here. Oh, you know what I'll do? Let me hot glue an eyeball onto there. These are too small for, here's a half a ping pong ball, but there they go. This is, you would need a larger sphere to actually rotate around the correct pivot, but what I'll do is just set this on the end of that dowel there. And so one technique that's used for animatronic eyes that's very similar to this is to use a universal joint, which is kind of what we've made here. Universal joint has two sort of coincident pivot points. Whoops, that's cooling while I'm hanging it upside down. And if you place that pivot right at the center, like I said, this sphere should be this big because we want the center of the sphere, the centroid of that piece of geometry, to be where both axes, these two axes are. So one technique is to take a U-joint, which you can get for remote control RC trucks and cars. You can find them at hobby stores. People will use one of these universal joints, glue it into the back of their ping pong ball or whatever they're using, and then you can attach your servos on 2 points to the ping pong ball's edges itself. So you can push-pull up, down, and you can push-pull left-right, and the U-joint takes care of finding all of that interpolation in between. So here you can see, even though imagine this is almost just the pupil, we can imagine that pupil looking up and down and left and right using these two axes of the gimbal. So that's our sort of tool and technique of the week, and it'll feed right into our project. Let's see. Oh, thank you, John Dubin. Did you say done to goodbye to the spammer? I hid them at least. Thank you, True Tech. You dig it. Yeah, this kind of stuff is really fun, and building these things at a larger scale and fairly quickly and easily in cardboard and sticks and glue is a really good way to wrap your head around it before you try to start making very precise miniature versions of them. And we're not going to make anything super precise today, but I'll show you a couple of versions that I've been working on, and maybe we'll sort of try to take one to completion. And then, of course, the software is another component. So you saw, if you saw that Instagram video, I have a version that just goes to some predetermined positions and kind of twitches around. I don't know if I have that code on here. I could put that back on that one. And then we have the version where I can use capacitive touch to sort of puppeteer up, down, left, and right. You can imagine using a joystick for this. In fact, if you remember, this is very similar to a pan-tilt camera project I made a little while ago. Since I'm not worried about making a sphere look like it's rotating around its center, the axes don't matter as much. But here you can see I've got two servos. So one servo rotates the other servo. Put that in that camera view as well. The other servo and that servo's own bracket. And so there's we've got up, down. On ours, we're actually, for the eyeball, for whatever reason, I have up, down as a larger servo that can move the whole mechanism, and then the smaller mechanism, or rather the smaller servo just does the left, right. So if you look online, and this is actually really interesting, I was researching animatronic eye mechanisms, and I found some Stan Winston school videos. If you're familiar with Stan Winston, he's a pioneer of animatronic effects and movie practical effects, special effects. And he has a program online you can go and learn about building maquettes and creatures and makeup and animatronics and stuff. A friend of mine, a guy I worked with back at Disney Animation 10 years ago, we both worked as character riggers, so we built creatures but on the computer. Well, this guy, Craig Caton Largent, had been a practical effects guy for decades before he got into the computer side of thing. I was looking at animatronic eye mechanism videos, and the one that randomly popped up for me was Craig doing Stan Winston school stuff, teaching you how to build really awesome little brass and wood gimbal mechanisms for eyes using little micro servos. So I was very delighted by that. So I'll put a link when I write this. I'm going to write a learn guide for this. I will put up a link. Oh, there goes my camera. I knew it. It's gotten hot. So let's turn that off for a second, and let me head over here. You know what I'm going to do? It's going to get loud, but I'm going to turn on air conditioning because it's that time of year again. So let's see. You know what? In fact, I can move up to this camera for a little bit to show some of these things, and then maybe that camera will come back to life. So let's hide that one, and there we go. So this is the mechanism. I kind of teased this last night on Show and Tell on Adafruit. I'll turn this off for a second. I can leave that part plugged in. So this is one way to do this mechanism. I'm going to talk about some of the pros and cons of these how I'm building these. So in this one, you can see it built up over time yesterday as I was trying things, lots of layers of cardboard, figuring out where pivots would go and where it needed to be stronger, and I shored things up with triangles and stuff, a little bracing. But what I'm doing here is essentially relying on this bigger servo to, as I mentioned before, turn the whole mechanism, kind of like with my pan tilt camera. So the up-down pivots right here, which is right where the center of the eye would be if I hadn't cut off into a dome. So that's rotating up-down. And then left-right is this other little micro servo. So that one's just riding along, let's see it that way. And when this little micro servo pushes forward, you can see it pushes the eye around this pivot point to look to the right. And when I pull that servo, it makes the eye look to the left. So I can just kind of manhandle it there a little bit. So let me turn that on. And this is running a version of that capacitive touch code. So, and this version of it is can be a little jiggly, but let's see if I can point the eye at you. There we go. And you can see this is my left-right. Here's my up-down. I can do both at the same time. Wiggle back and forth. And you can see, yeah, it's a little jiggly, and that's just because I used a kind of a naive technique in software to make this use the 4 capacitive touch sensors. So I used the same map technique that I showed you in MakeCode. I wrote this in CircuitPython. I essentially remapped what the values coming out of touch 1 are to be adding to the 90-degree to turn right, and then the other touch capacitive touch subtracts from it, and same up and down. So I'm either adding or subtracting to the value of 0 from a remap. That means that if I press both of them, they kind of fight each other. Let me restart this. But what it does mean is that if I can sort of smoothly touch them, and part of the idea would be to run some copper tape or some alligator clip wires so that I'm not getting my hands all on top of the two little sensors. But if I scrub from left to right, I'm touching the first pad and then I'm touching the second pad, and that's what. Get this a little closer for you. There. Now, here's an interesting thing about eyes. I think maybe some people are talking about this in the chat. I had to pay attention to this when I worked in animation because we would rig up eyes for control for animators to use in our characters for Disney movies. And the human eye, if you watch the way people look at things, it does a thing called a saccade, which is a very steppy, jumpy little move. So if you watch my eyes, I don't know if you can see it close enough, if I try to move them left to right, it's very hard for an eye to smoothly move when you go left to right unless you're looking at something. I'm going to track my finger. You can see that's me tracking an object. It's smooth. If you try to just look around the room, it steps and saccades. So if you're trying to make eyes that look at someone, if you're maybe building OpenCV based stuff or other sensing and you're trying to track and follow something, you're going to want very smooth linear interpolations that follow the motion. If you're trying to make eyes look like they're kind of glancing around a room, then you need to use these saccades, or you don't need to, but you'll get a little more realistic look out of it. So all of that to say, I'm not, it's not the worst thing in the world that these things sort of jump around. And if you look at, I can probably show this video. Let me add a track here for you to look at of a screen capture. I'll show you this video of this inside of the mask that I did. I just posted this to Instagram last night. And one second, and I'll probably lose my audio when I do this, so let's see if I can bring it back. So Firefox, let's see, is that going to show up? Yeah. Okay, and yeah, you can still hear me. So if you look at this, this was not using my capacitive touch. This was an earlier version where I just set it some values to go between, and that's just looping there so it jumps. But you can see that sudden jerk, it's creepy because I hit it inside of a mask, but that's all that you need to see of the eye. So you're definitely fine cutting your domes in half. And then as you make a higher quality, smaller, more precise mechanism, you can fit it closer to whatever eyelid and socket that you have. So this brings me to another topic, which is your number of servos that we're using for this. Right now I have 2 servos for one eye. What you want to try to avoid is using 4 servos for 2 eyes if you can, just because it's more to deal with and it gets more expensive. Unless you need your eyes to like cross or look away or do stuff like that. If you're, in most cases, if you're trying to have the eyes just stay in sync with each other, you're not trying to do any convergence as you look closer or anything like that. What you can try to do is build a linkage where one servo is driving both eyes for left and right, and one servo is driving both of them for up-down. So right now, if we had just this one servo, but a second sort of goggle here with the second eye, then we would run a linkage between the 2 eyes potentially, so that they move with each other. Now this gets to be hard to do with just little bits of wire and cardboard and sticks. But if you look online, you'll see if you start digging into real servo parts, there are little ball joints and little adjustable push rods and things like that that make it not too difficult to build pretty nice tracking between multiple objects being controlled by a single motor. So that said, it's very quick and easy to use. If I just got a second micro servo for the second eye left-right and use this same mechanism for up-down, you'd be done. So it depends on the sophistication of what you're doing and how much space you're trying to fit within. Oh, that's interesting. So C. Grover in the Discord chat says that he's experimented with, let me pop that up, some smoothed XY servo control in CircuitPython. Oh, that's right. He sent me this when I did my camera because it was pretty jerky. So I would love to look at this and see if we can use that to improve the motion of this. I'll take a look at that as I'm writing the guide. So thank you for the reminder. Okay, so that's one approach that you can take to this. And then let me see if I can turn on my previously overheated camera. And again, I apologize if the fan noise is loud as I try to cool off the shop. Yeah, it looks like the camera's back in action. Let me zoom that in there, like about so. So I can turn off this guy. And actually, you know what I'd like to do is take a moment to show you how I built the eyeball. So let's step over here and we'll put up this camera here. And yeah, let's use this pretty close-up cam. That's pretty good. So here's how I built them. So you'll start with you'll start with your ping pong ball, and there's usually a seam on there that you can follow. I can mark it up here so it's a little easier for you to see. I'm just going to somewhat imprecisely mark it up with a pencil. Okay, so you can see we've got one side that has no logo on it, so that's not a bad thing. It's not always the case. Sometimes the logo is arbitrarily placed on these, it seems. So you can simply go in with a knife, and I'm going to make this just a little, if I'm keeping this non-logo side here, I'm going to make my cut a little past the center line. And with a sharp X-Acto, you can just kind of saw your way through this stuff. Just be careful. It's okay if you're not making a perfect cut. I would just not worry about it. I suppose you could put it on a sander or something like that if you were trying to clean that edge up. It gets tricky right about here. Again, just to be careful not to cut yourself. If you can put some pressure on the two halves, they'll stay together a little better. And we'll trim off some of that excess if we need to. Okay, so you'll end up with a small half and a big half. We're going to kind of get rid of the small half. You may find it, once you've gotten it cut open, you can come in with some scissors and trim off some of the nastier excess, but that's fine. It doesn't really need to be perfectly flat there. And then what I've done for these ones I've been making is I'll take a piece of cardboard. This one will do. Big surprise there, right? Let me get one that's not, yeah, that one's fine. And you can just simply trace out the ping pong ball's diameter onto your cardboard and then cut that out. And we'll cut a little inside the line because what we want to do is fit that just inside here where we'll hot glue it. Or you can leave it a little big and hot glue this to the back of it. Either will work. This cardboard isn't so thick that it's going to throw off our pivot point by much. So now you can kind of work your way like this. Just cut that off so you can see it better. It's hard to cut like just a circle with an X-Acto knife, I've found. So one thing you can do is kind of like you're on the bandsaw, you can do a series of curves. Watch that thumb. Like this. Frankly, it's a little easier to cut these circles out with scissors if you don't mind dulling your scissors a bit. I do try to preserve my scissors, and I don't like to cut the cardboard with the scissors. It's cheaper and easier for me to just change out X-Acto blades. But amazingly, I think this was easier to cut a few hours of use ago on this same blade. Okay, so there you have your disc that we're going to set the eyeball on, and what we'll use is the fluting here. Let me make sure this is focused. Boop. We'll use this fluting as one of our pivots for one of the designs we can use. We can set a toothpick or something else through that, and then we can turn either horizontally or vertically through that one axis. So what we'll do is then just hot glue this on here, and I'll just run a bead on the inside and a little on the edge. Set this on here. Here, and I'm going to yank it with those little Spider-Man powers you develop when you're using hot glue a lot. True Tech, yes, a round blade would definitely be better. I think I have a scalpel with a pretty thin and curved blade, and this does work better, I've found. Thank you for the reminder. This does work better for, let's see, do I still have a blade in this? Yeah. So here's a scalpel blade that you can get nicer curves with. A lot of scalpels come with a fairly flexible blade. I think that's a number 11 blade when it's a bit flexible. This one might be this 10A, which is a little better. This is a cheap disposable. Actually, you can pull off the blades on these and replace them. So that's an option for sure. If you're doing a lot of curves, you might want to get a curved blade like that on a scalpel. You can get those kind of blades on an X-Acto as well. One nice thing about the scalpels, they have a flat body, which is a little easier on your fingers to hold versus the round X-Acto. Somewhere I had an X-Acto where I had built up some Sugru on there as a rubber-ish handle, which was nice. Okay, so here's our cardboard. Again, we can sort of trim that up. Go in there with the scissors just for this bit. And we're not making it the gimbal that it's going into so precisely fit for tolerances that this matters that much. But if you do get into making a higher precision eyeball, you will want to trim away that excess so that you're not bumping into the socket or parts of the socket mechanism. Whoop. Okay, so let's see. Oh my gosh, we're running low on time. So here's a couple quick things I wanted to show. One is just decorating your eye. One thing that I found worked really well is we'll just put a pupil on there like so, and it doesn't have to be perfect circle. It'll look a little bit organic if it's not quite perfect, and that's just with a Sharpie right there. And then this was an accident, but I was trying to get rid of the logo on one that I cut, and so I got a white paint marker. And what I found is this white paint marker, you can prime it, oh, it's got plenty of juice in it, is so much whiter than the underlying ball that you can do some nice sort of organic techniques where we end up with little striations in the sclera from that off-white part. And if this is too white for you, you could go in and dirty it up later. But this gives us kind of a nice definition of the sclera that has that kind of nice eyeball-y look to it. And then you could go in and create a colored iris if you want. I happened to just only have this sort of silver-ish gray Sharpie, which I thought actually ended up looking kind of nice on that example one I showed you. And you could exaggerate that, make it huge. This could be an animal eye, like a cat or something with a slit to it. But something like that works pretty well for your eyeball, especially depending on lighting, if this is like going to be a Halloween effect or something like that. And you could get in with some like pink or red and give this some other gross eyeball veins and things like that. But I thought that was a fairly quick and dirty way to get yourself something that looks a little more realistic, or interesting at least, if not realistic, than the ping pong ball. Okay, so let's see. Let's take a look. I want to pop over to this other camera real quick at more of a gimbal mechanism that I built. So this is just like our friend, the this 2-axis gimbal, except you can see here I've built up a little frame, and I just cut out a circle to go around the eye, which we can move forward and back using this servo. In fact, let me pop this off so you can see. Here we get our up and down. Let me put a pupil on there so you can see it. But let's put an animal one. There we go. So you can see here as we push this servo forward and backward, we're on one axis, and then this other servo side to side. Pop that off too. Come on, there we go. We're moving on our other axis. So now if I kind of imagine driving both of those, we can go looking all around. So what I found with this is that it's difficult to keep the side-to-side motion from imparting when you're just trying to go up and down. So I don't know if I'm going to go with this one for the final when I create the guide. I think I'm going to go with the simpler one, and that's mostly because these linkages are everything, and getting the motion of these and the coordination between them is really tricky using craft materials. What I have here is just pipe cleaners and straws to act as my servo arms, and they work pretty well, but let's plug it in and I'll show you what we're getting from it. Where is the, let's grab the Circuit Playground Express and Crickit we used earlier. Oh, good, I'm glad that camera is sort of holding out now that it's got some air. Can we use that one? No, you know what? That one, I'll grab the one we were just looking at because we put the MakeCode code on there, which is just a single servo on there. I didn't program the second one. But you can do that in MakeCode. You can go ahead and add the second one if you like. Okay, so we'll take the left-right one, and that's going to be in servo port 1 on the Crickit. Oh, there goes a straw. And the up-down will go into port number 2. Make sure those are lined up correctly. Then we'll grab power. And let's see, can you even see that? Let me move this guy out of the way. And, oh yeah, David Smith says in YouTube adding eyebrows for expressions would be great. Flexible links might help, for sure. Oh, so Todd, yeah, ToddBot. Hey, Todd. ToddBot mentioned that there's this great YouTuber called Look Mum No Computer, and he's a analog synth building guy and a total character, very fun channel, fun to watch. He built a animatronic eyes connected to a synth thing. I think I saw that a while ago. It was disturbing and great, except I forgot to look at it when I was doing this project, so I don't know what his mechanism looks like. Okay, so you can see that. So let's power this on. And hopefully those are still hooked up. Yes. Okay, so here's my up, down. Okay, so I'm going to bend my, let's go up a little. Bend my wire. So this pipe cleaner is just sort of doubled up, and you can see there. Let's see, how's it going? Oh, it's just mostly twitching. Yeah, it's not doing well. Let's see how left-right goes. Yeah, it's left. Yeah, so this mechanism is theoretically fine, but in practice it's kind of failing just because I have so much flex. Let me show you from the overhead camera. Or was that what I was showing you anyway? Oops, sorry, I was looking in the wrong monitor. I think this is what you've been seeing the whole time. Let me give you the front view. There you are. So there you can see from the front view. If I go left and right, it's just flexing more than anything else, and it's not wanting to actually push this. So there's the pull, and these little toothpicks I have in here aren't rigid enough, so yeah. So that should be shoving it to the right, but it's actually getting bound. Let's try it. Yeah, you can just see it sort of twitching, and here's up, down. It's one direction it kind of wants to go. So I'm going to revise this. I may go with that more direct one that I showed you before, which is going to be a lot easier to build with cardboard and craft parts like this. I may not give up. I may try to make this a little more rigid. It could just be I have so much flex and slop in some of these things that it doesn't want to work that well. But I would say if you're going to build this sort of thing in a workshop or a classroom environment using Crickit, simplicity is better. Everything is correct about this except for all the little details, and then it doesn't work. So this one that I showed before that I had made yesterday, I think is probably the winning design for this project, and that's just simply because it has fewer things that can go wrong. I have very little distance between hey, what camera is that? There we go. I have very little distance between this servo horn and the thing it's pushing and pulling, so less flex in that tiny little piece of wire. And then this one is, instead of a linkage, it's just directly controlled. So that's probably what I'll end up doing for the guide. So let's plug that back in and play with that for a second. And then we will wrap it up because we're 10 minutes over, my goodness. Let's see, so this is my left, right. I'm gonna turn this off while I plug these in. That's probably a good idea. Oh yeah. So Yanisku says in the Discord chat we could put a camera inside the animatronic eye. Very creepy, and I like it. All right, so here we go. Let's come back to this friend of ours right here. So there we go. Yeah, working a lot better. You can see the mechanism there. Let me zoom in all the way. Can you see that? Can it focus? Yeah, so here's the left, right. So it pushes, it pulls. And there's the up, down. Oh, sorry. Try that again. Up, down. Left, right. And obviously, part of your goal with this is often going to be to get the size of things down so that it can fit in the head. And usually don't have that much space off to the side. So that's why building things back behind it where you have some skull space if it's going into a head is a good idea. So that's part of the reasoning behind this type of design where most of the linkage and control is back behind. So that is our project for the day. That is our animatronic eyeball. I hope you've enjoyed that. Before we go, I'm going to turn off this air conditioner, because we're not worried about that camera anymore. And I will remind you that you can get 10% off in the Adafruit store with the coupon code SCLERA today. SCLERA is the white of your eyeball. Where's our eyeball? Where'd that go? SCLERA, don't forget. And head on over to the store. Check out stuff including the product of the week, the Itsy Bitsy M4 Express. I misspelled that. Oh well. So there's a coupon code. Check it out. And I will be hanging out in the Discord chat. Thank you, Yannick Murray. I'm glad you enjoyed the show. I'll be over in YouTube for a little moment, too, to say hi to people before that chat disappears. And I'll play us out with a little bit of funky music here. How about coming off the Pocket Operator? Sorry, I didn't have time to write a thing today, actually. I lied before. This isn't a song but written by me. This is a default on the Pocket Operator that I am just playing around with some effects. All right, well, thank you everyone so much for Adafruit Industries. I'm John Park. This has been John Park's Workshop, and I will see you next week. Look for the guide for this animatronic eyeball to come out next week as well. Bye-bye.